I'll let you know what you should probably take notes on. Okay? So we're going all the way back about 2,000 years to ancient philosophy. So again, don't write anything down until I tell you to. I'm trying to give you, I want you to enjoy this a little bit as much as you can. But the people we might be talking about are Aristotle and Democritus. Okay? Again, 2,000 years ago, where do you think this was happening? What country? Greece. Somewhere in Europe. Aristotle believed in 4 elements. Earth, air, fire, and water. He thought we were all made up of, everything was made up of those 4 elements. Democritus thought, no, that's a little bit too simple. I think there's probably tiny little particles we don't know about. And he actually coined that term atoms. So many years went by, and I think actually most people believed Aristotle. You might recall, or maybe you don't, or you should know, one of the most brilliant minds of the last 1,000 years besides Isaac Newton is Galileo Galilei. Yeah, that's how Galileo Galilei, yeah. And Galileo actually spent much of his time in the early 1600s proving Aristotle wrong at every turn. Aristotle was not a scientist. So these people, got to remember, they're philosophers. They didn't actually go in and do labs. They actually talked about stuff and inferred, and they didn't actually do things. Drew.
Aristotle and Galileo hate each other.
Okay, Aristotle lived more than 2,000 years ago. But it's a good question. But let's walk this another way. So he lived 2,000 years ago, so that's around, that's probably, I think, between 0 and 100 AD, something like that in Greece. Or maybe even before, I'm not exactly sure, so maybe even before that. And if you think about it, 1,600 years went by, people still believed a lot of the things that Aristotle preached. There's still people that believe that earth, air, fire, water. Not a lot happened in that 1,600 years, did it? I mean, that's what they call the Dark Ages, much of that, right? The Middle Ages and the Dark Ages. There wasn't a lot of advancement in humankind during that time, okay? But anyways, these guys, I always have a saying, philosophers are tourists, scientists are explorers, okay? These people don't get their hands dirty, okay? So really what you want to get out of this is probably this little piece right here. Democritus believed that matter was made of small particles named atoms. That's really what's important. But one of the famous ones, while you're writing that down, Galileo had to prove to people that a small ball and a little ball that have different masses will fall at the same time. That was the whole Leaning Tower of Pisa. Aristotle suggested that the large one would fall twice as fast or 3 times as fast. And everyone believed it. And then Galileo was like, well, I don't think so. Why can't we do the experiment? It's easy to do. And he did it, and believe it or not, the little one just dropped a hair second ahead of the other one, probably due to some wind resistance, because it was a smaller pebble. And people were like, oh, Aristotle was right. And Galileo was like, well, wait a second. He said it would drop 3 times as fast. They just missed each other by that much. And so his point was, no, Aristotle was wrong. So Aristotle made a lot of conjecture about things not necessarily true. And so there's Aristotle. There's Democritus. Oh, I'm losing it. Notice he's smiling because he knows he's right. He's wrong. Okay? And this sort of led all that time before the 1600s, we had alchemists, okay? You don't need to know all this information. They were all over Europe, Middle East, China, 800 to 900 years ago. And their work eventually went into what is now modern chemistry. Now I want to ask you, what were these people's main goal? What were they trying to do? They had a vision. Yes. Make money. That's he's right. He's right, but
make some cheap into gold.
Yeah, turning substances into gold. The most common one was lead, Pb. That was their goal. They were trying to change ordinary materials into gold. So Kevin is exactly right. Okay? And what happened is, and this is probably what I would like you to take notes on, Robert Boyle debunked alchemy. He's regarded as the first ever modern chemist. And he actually wrote a book in 1661 called The Skeptical Chemist. And in it, he showed all sorts of experiments that he did. He actually made his own glassware. His assistant was a guy named Robert Hooke, who turned out to be the father of modern biology. Okay, and they worked together, but Boyle paid Hooke. Hooke made a lot of his instruments, and he showed by measurement and math and stuff how a lot of what the alchemists did was just wrong. So he really sort of ushered in about the mid-1600s what we would now consider modern chemistry. Not long after he did this, lots of elements started being discovered, true elements, and they were being quantitated, and people were exchanging ideas. The problem with alchemists is some of them actually discovered elements, but they never told anybody. Why wouldn't they tell anybody? Sort of rhetorical question. Well, because they were trying to turn them into gold. They didn't want to give away the trade secret, right, if they could turn something into gold, so they were always very secretive. And so there's Robert Boyle. Yes, I can go back. Yeah.
So is there a chance that people that buy gold today, it's made out of some element nobody knows about because the chemists are trying to hide it from us?
I suppose, theoretically. I think if there was a chemist that was able to do that, at some point the gold wouldn't be worth as much. Supply and demand, right? Father of modern chemistry, there's Robert Boyle. Either that's his hair or it's a wig. I think it might be a wig. I don't know.
How is that not a wig?
Oh, I don't know.
He has to get a hairband for his experiments.
Yeah. And also I put up here, just for your viewing pleasure, these are some of the old alchemic symbols that were used. You still see some of these symbols today for the different elements. There was their element for gold. Get it? It's like the bullseye. X marks the spot. They were trying to get gold. There's a symbol for male. All different ones, and they had different names. So you might still see those today. But I just put that in there for fun. I won't have a quiz on them. So we're going to actually now skip forward from 1660 to basically 1808 and a guy named John Dalton. Okay? So another 150 years went by. People were discovering elements. John Dalton went back and thought about what Democritus said, and he thought about this idea of an atom because they were discovering elements on the periodic, well, not on the periodic table yet. That comes about 60 years later, but they were discovering elements, and he thought that, maybe these different things that we can't break down anymore, because the idea was they take stuff, they break it down, and then they'd burn it, do stuff that wouldn't break it down anymore. They were like, oh, it's an element. And he thought, well, maybe each of these elements has its own kind of atom. So this is really the key thing you want to probably take notes on, is that these tiny particles, each one of them corresponds to one of these elements that they're discovering. Okay? And this was a big jump intuitively. Early 1800s. And again, he was building on the ideas of Democritus from ancient Greece. See, at the time, in ancient Greek, they didn't really have that much of a concept of the elements per se, like what they were. They had isolated some elements. They called them like philosopher's wool and all sorts of different things. Okay? So I'm going to go ahead and move on. Again, the most important thing is that middle one where it says what. I'm kind of pushing the envelope here. So let's at least get through this part. And there's John Dalton, a picture of him. Did lots of different things in science. Yeah, they did wear wigs though, right? We know. 1808. I think that might have been just going out of style, right? They did it during the Revolutionary War. So discovery of electrons. So fast forward to like 1897, and so everyone thought there was just atoms, and then someone discovered, hey, these atoms are made of things. So that was actually 1897. J.J. Thomson, 1897. And again in England, a lot of this is going on in England, and he discovered that electrons are smaller particles of an atom, and he also, by his experiment, knew that they had a negative charge. By that time, people understood batteries, or the idea of a plus and a minus, and that particles had charge. And he was able to smack an atom and eject a particle from the atom and suspend it in a vacuum tube and actually see a beam of electrons. Okay? And everyone he already knew that atoms were neutrally charged, and he had isolated a negative charge, and so he postulated that there must be a positive charge, but he couldn't find it. Okay?
Oh, wait, was this the thing the textbook where it was the glass tube? And
Yep.
the two metal seals on the inside? Yeah.
So believe it or not, hopefully tomorrow in this classroom, I'll have one set up, and maybe in your lab you can come and check it out. I'll have the cathode ray tube is what it's called. It's really, most things like TVs and stuff ran on something called vacuum tubes. You might have heard of people say that. Old people talk about vacuum tubes before we had electronics. And this was one of the first vacuum tubes. Okay? Okay? Guys got that? Looks good. So there's this cathode ray experiment. I'm going to talk more about this, and I'll show you if you come up during class tomorrow or even Friday. We'll probably have access to it for a few days. We have one in the department. I know Ms. Page used it a couple days ago. Mr. Saran's, I think, finishing up with it today. But we'll talk more about that then. But what happened is, once he had discovered an electron, but he couldn't find a positive particle, Thomson proposed a model for the atom. And here's the model of the atom. He decided it was a circle. They liked the idea of a circle. And plum pudding is a big hit in England. People like plum pudding. And so the idea was that in plum pudding, you have this sort of goo that's, the plums that are got mashed, but you also have bits of plum. It's actually pretty good. And you have bits of plums. If you like plums, plums are good. You like plums. But anyways, he said, well, the little bits would be like a negative electron kind of floating in. And because he didn't know where the positiveness was, he said, everything else is positive. It's a positive goo. It's the pudding part. And so that was in 1898 kind of the accepted model of what an atom looks like. The accepted model. Bits of electrons spread into some positive goo. When they charges cancel to neutral atom. Okay? So the plum pudding model. You will definitely probably be asked this, maybe even an essay question on a test, believe it or not. The plum pudding model. Now, if you will go home and want to look at this further, there's actually an interactive cathode ray tube experiment, so a virtual one. We'll have a real one here tomorrow. And there's J.J. Thomson. Lived to be pretty old in the 1950s. There's actually still some YouTube videos up of him talking about science and whatnot. And there's his cathode ray tube is right there. Now, we'll just do this first slide and then we'll stop at that. The discovery of the nucleus. This is really important. Discovery Channel just had like the world's foremost scientists, Stephen Hawking, all these brilliant physicists, all these brilliant chemists, all the Nobel Prize laureates that are still alive. And they had them come up with their list of the most important discoveries. And this one, I believe, was number one. They said this was the most important discovery, the most important experiment in the history of humankind. Right here. Number one. The discovery of the nucleus. Who discovered the nucleus? Anybody? Said yes. They have an element up here. Rutherford. Yeah, R.F. Rutherford. His name, Ernest Rutherford. Ernest Rutherford did this in 1911. Remember, J.J. Thomson said, hey, I don't know where the positive particle is. I know we have a negative particle. It's called an electron. 1897. So for the next 15 years, everybody around the world, all these scientists were trying to find a positive particle. Ernest Rutherford did this in England. I should point out he's actually from New Zealand. Ernest Rutherford probably assembled the greatest group of scientists ever, young people that worked under him and ended up winning Nobel Prizes. They made all sorts of discoveries from about the early 1900s up to the 1930s. So really brilliant, a brilliant scientist. In some ways, every bit as brilliant as Einstein. Okay, kind of a working man's Einstein. And what happened is he conducted an experiment to isolate the positive particles in an atom. And his discovery, his experiment, decided that it basically led to the idea that atoms are mostly empty space and that almost all the mass is in the very middle. This is exactly what I did yesterday with the demo, where you had your electron cards and I had my nucleus. Okay? His model was, here's the nucleus, all the mass, a few electrons out there, mostly empty space. He did an experiment to prove that. Okay? So what happened when he was done, we now had a positive particle and a negative particle. What was really left was, how are they arranged? So it turns out that the rest of the time, from the next 20 to 30 years, people try to understand how electrons are arranged in an atom. It actually led to something called quantum theory, which they still use in science today. You hear this word quantum mechanics. And when you learn about quantum mechanics, it's kind of crazy. It'll blow your mind away. So I'm going to just leave it there. You can maybe jot one more thing down. That was his experiment. It's called the gold foil experiment. We'll stop right there. We got a few things to do.